this problem is to determine I1, I2, V1, and V2. If we notice in our circuit, we have an ideal transformer. So we're going to utilize our problem-solving strategy anytime circuits containing ideal transformers. First step, that strategy says to carefully examine the diagram, determine the assigned voltage, polarities, and current directions in relation to the dots. And if we notice, V1 is positive at the dot, but V2 is negative at the dot. So we'll have V1 over 4 is negative V2 over 1. So, for instance, V1 is negative 4 V2. And if we look at the currents, we can see that both currents are entering dots. So that gets us a situation where 4I1 is equal to minus I2. Okay, this is N1 I1 equal minus N2 I2, and that's because if we look, both currents are entering dots. So that gives us our relationship. Now, there are no electrical connections, so now we will reflect circuit elements through this transformer. So what I'm going to do is I'm going to move everything on this side over to this side. We could just easily move everything here over to there, but let's take all the elements here, move them over there. Now when we go through the transformer, this minus sign, what's going to happen is we have a voltage source that's 100 at 0. When we go through that transformer, because of this minus sign, it's going to become minus 25 at an angle of 0. And what I'm going to do is I'm going to turn that voltage source upside down and write it as that. Now if you remember, we reflect the impedances by the turns ratio squared. So now reflecting all the impedances over here through this transformer yields the following circuit. So here's our voltage source, and here's our 32 ohm that we divide by N squared, and N is 4, so we divide by 16. This becomes J1. This becomes minus J1.5. So now we can just apply KVL to this circuit. This is a single loop circuit. So if we go in, we'll have 2I2 dropped here plus J1I2 plus 3I2 plus J2I2, which is a drop here, plus 20, and angle of minus 20. Coming back around, we have minus J1.5 times I2 plus 25 at an angle of 0 equals 0, so that's just KVL. So we have 5 plus J1.5 times I2. We have minus 25 minus 20 and an angle of minus 20. So if we solve this for I2 turns out to be 8.49 and an angle of 154.42 degrees. So we solve this equation, solve for I2. Now, for V2, we can take KVL around this loop. V2 is 3 plus J2 times I2 plus 20 at an angle of minus 20. And that's 16.04 at an angle of minus 135.9 degrees. So there's V2 and I2. Now we can go back to these relationships to calculate V1 and V2. So for instance, V1 is minus 4 V2. So we have minus 4 times 16.04 and angle minus 135.9. So that gives us V1 is 64.16 at an angle of 44.1 degrees. And I1 is minus 1/4 I2. So we have minus 1/4 times 8.49 at an angle of 154.42. And I1 is 2 at an angle of minus 25.58 degrees.